So we continue to talk about graphing, and in general, we need to get a handle on amplitude, period, and phase shift. And I really haven't explained phase shift, and I'm going to do a demonstration in a moment. But if A is not equal to 0 and B is greater than 0, then f as a function of t, a sine bt plus c, and g equals a cosine bt plus c, has amplitude absolute value in A. The reason why there's an absolute value is if you have this, minus 5 sine t, the amplitude is just how far it's getting stretched. Now the minus is going to turn the thing around at first, but they don't care. They just want to know how far it's stretched, okay? So that's why it's absolute value. The period is 2 pi over b, and somebody could say, hey, you just said the period was 2 pi over k. Well, I tend to use k. The book I just looked into that you're using at this time has a b, so I thought I'd be friendly with it. It doesn't matter. Whatever's in front of the variable here, and they wanted this to be b is greater than 0 because depending on whether it's sine or cosine, different things can happen if it's less than 0, and you just have to be careful with it. But so this is the period, and also period is a positive number as well, simply because a period is just talking about how far it goes to repeat itself. A negative period doesn't make a lot of sense where we are right now. You'll notice, remember from algebra, there were, if you had solutions of quadratic equations and the formula was a time formula, sometimes it would be like negative 10 seconds. In general, the physics that you'll probably be doing for a while, time doesn't go backwards. It's negative time doesn't show up. In the physics I'm doing, it actually does, and it's pretty neat. I hope you get there sometime. But anyway, so the period is 2 pi over b. The phase shift is minus c over b. And you might be saying, what is the phase shift? The phase shift is, so we know that cosine, so to speak, I'm really off today, so to speak. Cosine, so to speak. What does that mean? Cosine starts, when x is 0, cosine starts at 1. Phase shift means changing where it starts. And think about it, if we know that cosine of 0 is 1, where is this going to be 1? Well, it's going to be 1 when whatever's inside here, bt plus c equals 0. That means that bt equals minus c, or that means that t equals minus c over b. That's what they mean by phase shift. Phase shift is, we usually start cosine right here, but by putting something here, we can move it over. And this becomes very convenient. And now I would like to show you that, in fact, sine and cosine are the same function, just shifted over. And let's take a look at that. First, we will, so let's take a look and see that sine of x and cosine of x are really the same function, just phase shifted over. And I will put up pi over 2, pi, 3 pi over 2, 2 pi. Let's put up cosine. Cosine 0 is 1. I should put these up. So we already know that cosine looks like this. Decent drawing here. Okay, so this is cosine x. What does sine of x plus pi over 2 look like? Well, I'll use a different color for that. When x is 0, sine of pi over 2 is going to be 1. So this is our first point. When x is pi over 2, sine of pi over 2 plus pi over 2 is sine of pi, that's 0. When x is pi, this will be pi plus pi over 2, which is 3 pi over 2. We know that sine 3 pi over 2 is negative 1. Similarly, these are going to follow the same way through. And so what you can see is that these are the same functions, just shifted over by pi over 2. Okay, let me see what else I want to do with this. I think you have enough to do all the homeworks that you've been asked to do for these. Pretty much all the problems are just going to say, what's the amplitude, what's the period, and what's the phase shift. Maybe we should take a look at a sample problem. Oh, what's a good one? 3 cosine 3t minus pi. 3 cosine 3t minus pi. A question that you're going to be asked undoubtedly on the test will be, what is the amplitude? This is our A. The amplitude is the absolute value of 3. This is just 3. What is the period? Well, this is in your book that you're using now is B. I really like using K. If I accidentally start using K, don't be mad. And this you just have to memorize, although hopefully it's somewhat obvious why it's true. But so the period is going to be 2 pi divided by B, which is just 3. What is the phase? And usually students have a hard time remembering this. And what you have to do is just remember, when is this 0? Ask yourself, when is this 0? So when is 3t minus pi equal to 0? That is precisely when 3t is equal to pi, or t is equal to pi over 3. And so the phase is equal to pi over 3. And remember what the formula for phase was. It was minus c, which is minus pi, oopsie, divided by b, which is 3. You can see these are the same thing. Those of you going on into the serious sciences are going to use this analysis a very great deal. Everything from springs, sine and cosine, and the trigonometric functions play such a major role in basic physics. They show up everywhere. So let me show you, actually so this is all you need to know to complete your homework. We have a little more time on here. Let me show you some things that will be helpful to remind you. One of the things that shows up all the time in calculus is secant and tangent, or secant squared. Let me introduce some of these new functions. It's a little early, but it's better if you see them first. Remember, for this picture, for this triangle, here's y, here's x, here's r. By definition, we'll let this be alpha again. We know that cosine of alpha is x divided by r. The sine of alpha is equal to y divided by r, and the tangent of alpha is equal to sine alpha divided by cosine alpha. This is actually equal to y divided by x. You'll notice that the tangent then, y divided by x, this is the rise, this is the run. If you were thinking about the lines that you were graphing in algebra, this is just the slope of this line, right? Some more functions that are going to be coming up, and these you will have to know. You get a couple weeks before you really have to know them, but these are very important to calculus. Dealing with cosine, we're going to have cosine upside down, 1 over cosine alpha. This is called secant alpha. 1 over sine alpha is called cosecant alpha, and 1 over tangent alpha is called cotangent alpha. And we need to take a break. We'll be back in just a moment.